Okay, so we'll talk about our Numpy to solve linear algebra problem, right? These problems are very much like your 9th, 10th class problems where they said that, my father, 5 years back, my father was twice of my age. Now he's twice of my age. What is my father's age, right? And what is my age, right? So first thing is that statement has to convert it into equation. So let's say we get this equation. So we get 2x plus 5y plus 2z, okay, equal to minus 38. It can be any number of variables, okay. So we know that, if you have three variables, you need to have at least three equations to solve the problem. If you have three variables, you can't solve them using two variables, right? So we have x, y, z, three variables. So we need three equation to solve. So this is your first equation. Let's create our second equation, which is, let's say 3x, okay, minus 2y plus 4z equal to 17. And then you have minus 6x, okay, plus y minus 7z equal to minus 12. Okay, so we'll try to solve this equation. So before we solve this equation, let's understand, what I'm doing here or what I'll be doing here. Let me share paint here. Okay, so we need to form, or we will be forming three matrices. Okay, we will be forming three matrices. So you have equation like this, correct? Which is equal to something. Can you guys go on mute? I think I can hear my echo sound. Sorry. Okay, equal to this. So you have three variables. So we'll form a matrix X, Y, and Z. Okay. So how many rows, how many columns? This is your 3-row, right? 3 into 1 matrix. Okay. So these are the values, unknown values, right? And then here we'll call, this is your unknown value, and this will be a coefficient value. Coefficient of x, y, z, right? So, you'll have coefficient of x, y, z, x, y, z, x, y, z. So this is your 3 into 3. And this is equal to, and this is again going to be your, this is called constant matrix. Constant means the output. And this is again 3 into 1. So you see, 3 into 3 into 3 into 3, it is possible to perform matrix multiplication, and output is going to be 3 into 1. This is what we got. So we know this value, we know this value, we need to find out this value, isn't it? So what we'll do is we'll bring this one this side. So when you bring this matrix this side, this becomes inverse. Yesterday we learned how to calculate inverse, right? So it becomes inverse, and this is what we'll do. So your output, okay, your xyz value is going to be this inverse, right? And we'll write inverse as -1 into multiply into the constant value. So find the inverse and multiply with this. This will result into some value, and that is your xyz. Did you understand the logic? What we're going to do now? Three of you. Did you understand what we're going to do now?
Yeah.
Correct? Yes. So we will find the inverse of this matrix, multiply with this constant matrix. That is nothing but your output matrix xyz. So let's go back to our pie chart. Okay. So let's first form coefficient matrix. So I'm going to say coefficient matrix equal to, coefficient equal to, okay. First, let's form that list. So we have 3 rows and each of them have 3 columns. So what are the matrices, what are the indexes here? +2, +5, +2, right? So 2, 5, 2. Here, what is the coefficient here? Tell me.
3 minus 2, 4.
3 minus 2, 4. Yes. 3, comma, minus
Minus
2, comma, 4.
4.
And, okay, why did I close here? No, this should be closed here, right? Yes. And what should we put here?
-6, 1, and -7.
Perfect. Okay, -6, 1, -7. This is your coefficient matrix. We need to figure out the inverse of this. So, but before that, we need to convert into coefficient matrix, right? So, I'm going to say coefficient matrix equal to your, okay, we have to import NP. So, import Numpy as NP, and I'm going to say NP dot array. Okay, and you put your coefficient here. So this will result into coefficient matrix. Now, inverse of this is possible if the determinant is non-zero. So step 1 is to find the determinant of coefficient matrix, right? So I'm going to say coef determinant equal to, how do we find determinant? NP dot lin algebra dot determinant, and you pass coefficient matrix. Okay. If coefficient det, okay, equal to 0, then you say print this or these, or there are no possible solution for given equations. Okay. Next, else. Else means yes, it's possible. So we need to go next step. What is the next step? B. Okay, or your constant matrix. So what is a constant metric? Constant. Let's first create this constant here. Equal to. So first row you have only -38. Correct? Second row you have only 17. So it is 3 by 1, right? So you end up creating something like this. Right? Now you need to multiply the inverse into constant. So coef matrix inverse equal to np dot lin algebra dot inv of coefficient matrix, right? And how do you perform multiplication? Okay, so I'm going to say solution, okay, equal to, yeah, matmul. So I'm going to say this is your inverse, right? So np dot matmul, okay, first this inverse matrix, okay, first you put this inverse matrix, which is coef inverse, okay, comma, multiply this with constant. This is just solution. Print solution is solution. Okay, and you run it. So see, and if I can give /n, let it come answer the next line. 3 minus 8 minus 2. So it says, or you can even say that solution is, or you can say x equal to y equal to z equal to, right? And we will learn how to give these answers here. Okay, so the solution is a matrix. The solution, okay, first row, comma, first column. This is your X. Solution, second row, first column. Right? Column is only one, isn't it? And then Z is your, again, solution of third row and first column. See, 2.9999 means 3 only. 7.9999 is 8 and minus 2. So these are your solution here. Okay, you can substitute back in the equation and you will get the answer. Easy, isn't it? Okay. The key here is to know which data structure to use. Once you know that, okay, I need to use Numpy, you have all the methods here. You have methods to perform determinant, methods to perform inverse, method to perform multiplication. You just have to call them in right order with right values and you get the answer. The data structures, job of data structure or the collection that we call is to mimic real world situation, okay, so that you can frame real world problem into mathematical, a real world mathematical model into programmatical model, and then you solve it. Great. Any questions so far?